to scratch this one out. Well, actually, we'll just add one in. Okay. Example 2.2 instead of just the 2.1 we did up here. Okay, so let's try this. I'm going to give you the inequality 3y minus 4x is less than or equal to 12. Now we're going to go ahead and solve this. I wanted to give us one where we have to solve it, so I'm going to add 4x to both sides. I get 3y is less than or equal to 4x plus 12. Divide everything by 3. Y is less than or equal to 4/3 x plus 4. My slope is 4/3. My y-intercept is 4. I'm ready to go ahead and graph. So I'll make a little makeshift graph right here. I'm going to plot my 4. I'm going to go up 1, 2, 3, 4, put a point, and then I'm going to do my rise over run. So 1, 2, 3, 4, 1, 2, 3. So again, this is a rough sketch, but just to get an idea of one more practice one. Is it a dotted or solid line? It's going to be solid because we have that equal to in it as well. Didn't go through that point. There we go. And connect it. So it's solid. And now we have to do our shading. So we're going to pick a test point. Again, 0, 0 does not fall on my line, so I'm going to test 0, 0. So I go ahead to my inequality. I can use either the original or the one that I rewrote and solve for function form. I get 0 is less than or equal to 12. Is that true? Yes, it is. This time we do have a solution. So I'm going to go ahead and whatever side that test point was on, that means that whole side gets shaded because it's part of the solution set. Okay? Then we shade the bottom there because that's where our test point was. Good job. All right, now we can come back to graph 3. Graph x less than 3. So you might be thinking, well, wait a minute, we don't have a slope. We don't have one. We don't really have a y-intercept. So how do we do this? Hopefully you remember when we graph just the x, when it's just one variable, these are like special cases. What we do is we find 3, 1, 2, 3, put a point, and that means this whole line is going to be a whole vertical line, not just a point, but it's going to be a whole vertical line. Now this one's going to be dotted because we have just less than. So a dotted line. And then we're going to test a point just like before. I can pick 0, 0. So I go to substitute zeros in for x and y, and I don't have a y, but I do have an x, so I put 0 in for x. Is 0 less than 3? Yes, it is. So that means this side contains all solutions. And really, if you were in question, you could go back, and really what that means is any point, any one on this side, all the way up and down the left side of that line is going to, when substituted in, is going to work. Every single point will make that true, that inequality true. That being said, let's try this one. This one, again, we only have one variable, y greater than or equal to -2. So we don't have, our slope is 0. Our y-intercept is -2. So we would go to y-intercept of -2. This is going to be a solid line straight across. And we're going to go ahead then and shade. Now this is all the y values greater. So I could pick a test point, 0, 0. Plug 0 in. 0 is greater than or equal to -2? Yes, it is. So everything north is my solution set. It matches. It says the slope is 0, straight line, 0 slope, like the treadmill, no inclination, and we're good to go. All right, now I want to show you one thing. We're done with the lesson, but I want to show you one thing to help you with the shading. I may have to, let's see how white looks. Oh, that's kind of hard to read. Okay, maybe I'll just make it in black. Some people have a little bit of trouble, even with the test point idea, figuring out when to shade where. It's kind of another simple concept is to think this. This inequality says y greater than or equal to 2x plus 4. So if I kind of envision, back when we were talking about slope, if I envision, make it a little darker, like the guy walking up the hill, he's going up the hill, okay, he's right there. The way I figure out what I'm going to shade is based on this inequality sign. If it's greater than or equal to, then I shade the side that he's on. Okay, I shade all of that side. It's almost like this is the ground. If I had less than, that would be everything underground. I don't want to shade that side. I want to shade everything where he is, above ground. Okay, so that's the greater than or equal to. And I just want to show you on this page how it comes through here as well. So I have this guy. He's going downhill. This is a greater than. I look at my final because that's what I actually graphed in slope-intercept form. Greater than. So that means I shade everything above the line because that's greater than. All the y values greater than the line is what we're saying here. There we go. Okay, example 3. Well, actually, we'll skip to our example 2.2. The guy would be walking up the hill like this. He can't be down here. That means he'd be upside down. So he's walking up the hill or running or whatever. And we go to our inequality that we have in slope-intercept form. This one is less than or equal to. Y is less than. So we want all the y values lower than the line. If you see less than, that's like means we're less than the ground. We're underneath it. And that's how you get that. Example 3, x is less than. So these here, this x value is less than the line. This is 2. This x value is less than the line. This is less than the line. And that's another way of thinking, oh, all these x values are less than. Lastly, this is y greater than. Greater than, like we said, if we have our guy just hanging out, maybe dancing, all the y values greater than that -2 are all the ones that are going to be above it. This is y equals 0, y equals 1, y equals 2, 3, 4, 5. All those values are greater than -2. And again, greater than also implies like above ground where the guy stands, okay? So hopefully that helps with some shading. Remember to remember, graph normally, solid or dotted line, and then shading. Okay, great job, guys.